Okay, to find areas of a circle and areas of a sector, we have some things that we started with at the top here. Um, we need to remember that the formula for area has to do with radius. And so the radius starts at the center of the circle and goes out to a point on the circle. But sometimes you'll be given the diameter, which goes all the way across the circle through the center. So just as a reminder, the radius, oops, is part of the diameter. So that's why 2 radii would make a diameter. So if you had, let's say, a diameter of 10, then you know the radius is 5, etc. The other thing to note is that this pi, we're going to use the button on the calculator. When you were a kid, maybe you used 3.14. We're going to use the button on the calculator and get this long decimal. Pi actually goes on forever without repeating and without stopping, but we're going to at least get more of it than just 3.14. So area of a circle is all the inside of the circle. Like if you had a pizza, it would be the whole pizza. The area of a sector would be just a slice of pizza as long as you cut it so it went to the center. The slice of pizza that you take out is a sector, but also the rest of the pizza that's left over is another sector. So the area of a sector is a fraction of the area of a circle. And that fraction is how many ever degrees we have here out of 360 because a circle is 360 degrees total. So to practice, we're going to start with just the area of a circle. Remember that when you see a problem, you can always say, what is the problem asking me to find? It's asking me to find the area of the circle. And it actually specifically says find the exact area, which means I'm going to leave it in terms of pi, and find the area to the nearest hundredth, which means I'll put pi in the calculator. And we'll talk about both ways to do that. So when it says area of the circle, I am going to first choose my formula. And then I will put in what I know. Pi is a number in the calculator, so I can't put anything there. I could put in an area if I knew it, or I could put in a radius if I knew it. So here I look at the picture and I see that my radius is 2 inches. Just like in earlier unit sections, we have said we are going to write the formula and then label the picture and then put in what we know into the formula from that picture. So pi times 2 squared. Okay, and then just a side note, you may or may not remember, please excuse my dear Aunt Sally. We need to do exponents before we do multiplication. So we've got multiplication here, but we need to do the exponents first. So we need to do 2 squared, which is really 2 times 2. So that gives me 4. And then I will do that times pi. Now here's where the exact and rounded come in. So the exact answer would be 4 pi, and it's square inches. That is exact, but that is not the same as just 4. So if I now go and put this in my calculator and I do 4 times pi, I'm going to get 12 point, let's round the 6 up to a 7 because there's a 6 next to it. So 12.57. Let me double check that's right. Yes, 12.57. That's the rounded answer. And people forget to put the pi sometimes and they say, oh, 4 is the same thing. But 4 is not the same as 12 and a half. Running 4 miles does not feel the same as running 12 and a half miles. So please be careful with that. If you don't have a calculator and you just want to leave it as 4 pi, that's perfectly acceptable. Okay, for number 2, it tells you the area of a circle. But again, area of the circle is the formula that I will use. So area equals pi r squared, pi times r squared. And I want to find, what am I looking for? Find the radius. So this is the thing I'm looking for. And I actually know the area is 58. So I will put that 58 in place of the A because that is the area. And then I'm trying to find what R is. So going back to the please excuse my dear Aunt Sally order of operations, when you are solving, you're going to undo the order of operations going backwards, except we always do parentheses first, but we'll undo backwards. So I undo addition and subtraction, then I undo multiplication, division, then I undo exponents. So this kind of has to stay together, and I got to get rid of the pi first because that's multiplication. I got to undo that multiplication. So I will divide by pi to undo that multiplication. And that will give me some decimals. So I'm going to do 58 divided by pi in my calculator. So 58 divided by pi. And I get a long number. And I'll write 18.46 on here, but I don't want to just round it to 18.46. So I'll say 18.46 ... because I'm going to keep that in my calculator. That is what R squared is. But then to just get R, I need to undo the exponent. So the way to undo the exponent is to do the square root. So I'll take the square root of both sides. And this is what I want to show in your calculator. You can square root the answer. So you can do second squared, that's the square root. And then right down here above the negative is answer. So this will take that whole answer, so you don't have to retype it, and it will square root it. So now I have 4.29, but next to the 9 is a 6, so I'll round that up to 4.30. So 4.30. Okay, number 3 asks me to find the area of a sector. So you already saw the answer that I accidentally left there. But area of a sector, I will start with that formula for area of a sector. So I have the area of the sector is the measure of arc AB times pi r squared, pi times r squared, out of 360. So the measure of the arc is how many degrees is the arc. And so you can see right here, this is 90 degrees. And remember we said in first semester that the central angle is the same as how many degrees that arc is. So that's 90 degrees. And then the radius is the other thing that I need to find. And so the radius, I can look on my picture, and the radius is right there. The radius is 6 centimeters. So now I can put all of this into my calculator. I'll just put it all in. So I'll do 90 times pi times 6 squared divided by 360. And that gives me 28.27. Next to the 7 is a 4, so I'm going to keep it at 28.27. And that is square centimeters because the radius is in centimeters, which then got squared.